Trigonometry is a branch of mathematics that studies the relationship between the side and angle of a triangle. More specifically, it is all about the right angle triangle where the internal angle is 90 degrees. It helps us to solve or to figure out the missing or unknown side lengths and angles of a triangle. We have a problem number 1 here. A ladder 42 feet long is placed so that it will reach a window 30 feet high on one side of a street. If it is turned over, its foot being held in position, it will reach the window 20 feet high on the other side of the street. How wide is the street from building to building? So the first we need to do in solving a trigonometry problems, we have to illustrate the problem. So we have here the building A, which is 30 feet high. 30 feet high. And we have, or let's assume that this is the window. And it is said that the ladder reached this 30 feet high building. And the ladder is 42 feet long. Yeah, so we form a triangle here, a right triangle here. Next is, if the ladder is turned over, it will reach the window, which is 20 feet high. So let's say that this building, and here is the window. It is 25 feet high. But the length of the ladder is the same. Okay. So the question is, how wide is the street from building to building? So this is the building A. Let's assume that this is the building A and this is the building B. Let's assume, so this is the distance from building A and B. So in order to solve this distance between the two buildings, we have first to solve the distance between the ladder or the foot of the ladder to the building A, or the foot of the ladder to the building B. But let's solve this building A first. So in order to get the other side of the distance between the foot of the ladder and the building A, we have to use the Pythagorean theorem formula. So the Pythagorean theorem formula is c squared is equals to a squared plus b squared. So a squared and b squared is the side of the triangle, while the c squared is the hypotenuse. So here is the hypotenuse, which is 42 feet. 42 feet, but let's squared is equal to the a squared and b squared. The 30 feet can be a squared or b squared. It depends on you which of them is the a squared or the b squared. But I am going to use 30 feet is the a squared. So 30 feet is the a squared plus b squared. So this is the a, and this is the b, and this is the c. Then let's square. So we need a calculator, but you can do it manually, but it is faster to use a calculator. So we have 42 squared. We have 1,764 feet. 30 squared is 900 plus b squared. Next is, let's transpose the 900 into the left side. So we have 1,764, and the positive 900 will become negative. So it will become negative is equals to b squared. Then subtract. So we have 864 is equals to b squared. Then since the b squared has an exponent, so we have to square root both sides. we have to get the square root of the both sides. So the b squared will become b. Then 864, or the square root of 864, we have 29.39 feet. So this is the how wide, or the distance between the foot of the ladder and the feet. So we have here the 29.39 feet. And the next side here, we have to find the distance between the foot of the ladder and the building B. So we are going to use the same formula. So we have c squared is equal to, so we have c squared is equals to a squared plus b squared. Let's use big letters since we already used the small letters. So c squared is the hypotenuse again. The ladder is the length of the ladder is the same, 42 feet long. So let's square is equal to a, which is the 25 feet. So let's assume this is b and this is c. So a squared is 25 squared plus b squared. So the 42 squared is the same. We have 1,764 is equal to 25 squared is 625 b squared. Then let's transpose the 625 to the left side. We have 1,764 minus 625 is equals to b squared. So minus 1,764, we have 1,139 is equals to b squared. Then let's get the square root of b squared and 1,139. So we have b is equal to square root of 1,139. We have 33.75 feet. So this is the distance between the foot of the ladder and the building B. So in order to get the distance between the building A to the building B, we have to add the distance letter B and the distance of the uppercase B. So we have B. In order to get the distance, we have, or let's say the whole distance is x. So in order to get the x, we have to B plus B, or the distance of the building A to the foot of the ladder and the distance of the building B to the foot of the ladder. So our small b is 29.39 feet plus b, which is 33.75 feet. So if we add them, the answer is 63.4 or 14 rather feet. So this is the distance from the building A to B, or this is the 63.14 feet wide is the street from building A to building B. So this will be our final answer. So we have the problem number 2. From a window 30 feet above the ground, above the level ground, a building 150 feet high and a distance of 200 feet is observed. Find the angle of elevation of the top of the building and the angle of depression of its base. So first, let's illustrate the problem. So it is said that this is, or the window is 30 feet high above the level ground. So let's assume this is the level ground, this is the window. So this line is 30 feet. Then there's another building which is 150 feet high. 150 feet high. Then the distance between the window and the building is 200 feet. So this is 200 feet. Then the problem is to find the angle of elevation of the top of the building and the angle of depression of its base. So this is the top of the building. So this line is the angle of elevation. If this is the object and the line of sight, which is this horizontal line, and if you look up, the angle here is what you call the angle of elevation. While the angle of depression, if the person is here or the object is here, the line of sight is this horizontal line, and look that. So this angle is the angle of depression. So the angle of elevation, let's label it as the angle A or alpha. At the angle of depression, let's label it as angle B or beta. Then our angle of elevation, which is A or alpha, we were going to use let's write the SOHCAHTOA. We are going to use the TOA, or the opposite over adjacent, while the angle B or the angle beta is adjacent over hypotenuse, or the CA. Then first, let's solve for the angle alpha. We have tangent A is equal to opposite over adjacent. So we have the opposite, we have 100, but we are only going to use this part, the line of sight, until the top of the building. So this one is 100 minus 30. We have 100 minus 30. Because this is 100, the building is 100 feet high, and below the window is 30 feet. So we will just have to subtract them over the adjacent, which is in the horizontal line of sight is 200 feet. So we have tangent A is equal to 70 over 200. And tangent A, if we had to divide them, it will become 0.35. Then let's find the angle alpha. So we have tan or tangent alpha is equal to we have to alpha is equal to tangent yung with negative 1 times the 0.35. So the angle alpha is equal to 19.29 degrees. So the angle of elevation is 19.29 degrees, this angle. Then the next step, in order to get the angle of depression, first is I am going to choose the long method. First, I am going to use the Pythagorean theorem, which is c squared is equals to a squared plus b squared. So we have c squared is equals to a squared plus b squared. Your c squared here is this one, the hypotenuse, and the 70 feet is here. We have 70 feet here because it is 100 minus 30. So this side, or from the line of sight of the window to the top of the building, is 70 feet high. So a squared, let's use it as 70 squared, plus the b squared is the 200 feet here, this side of the triangle. So we have 200 feet squared. So c squared is equals to 70 squared. We have 4,900 plus 200 squared. We have 40,000. If we add them, it will become 44,900. Next is let's find the square root of both sides. So c is equal to square root of 44,900 is 211.8 or 0.90 feet. So this is, the length of this line is 211.90 feet. So we can get the angle B by using the cosine, adjacent over hypotenuse. So we have the angle B. Since we already get the length of this line, or the hypotenuse, then next is 200 feet, or B, or the adjacent, which is, or let's say the x. We have 200 feet. The adjacent is here at the top. It's the length of the top here, or the distance here and here are the same. So it is the same 200 feet over the hypotenuse, which is the 211.90 feet. Let's write it again. We have the angle B is equals to 200 over 211.90. I forgot, it's cosine. So the cosine of angle B, let's divide 200 and 211. We have 0.94. And the angle B, cos -1 multiplied by 0.94, so we have 19, or the angle B is 19.95 degrees. Oh, 19.29 rather. 19.29 degrees. So this is the angle of elevation. We have 19.29 degrees, and the angle of depression is also 19.29 degrees. So we have the third problem here. To measure the height of a building, a surveyor sets up his transit at a distance of 112.2 feet from the building. He finds the angle of elevation of the top of the building to be 48 degrees 17 minutes if the telescope of the transit is 5 feet above the base of the building. How high is the building? So first, let's illustrate the problem. So we have here a building. So let's say this is the building. Then a surveyor set up his transit across with a distance of 112 0.2 feet from the building. So let's say this is where he set up his transit. So the distance between the building and the transit is 112.2 feet. And the angle of elevation of the top of the building, so if we say the angle of elevation, it is when you look up. It is when you look up. So this one, or the angle is this angle is 48 degrees 17 minutes. Then, if the transit is 5 feet high, okay, so this is the label of transit. So this is 5 feet high. This is also the same. It is also 5 feet high. So the question is, how high is this building? So first, let's convert the 48 degrees 70 minutes into decimal. So we have to convert the 48, let's say that this is, we have 48 degrees 17 minutes. So to convert this, we have 48 degrees, then let's multiply the 17 into 1 over 60, because in minutes, in 1 minute, we have 60 seconds. Then we have 48 plus 17 over 60 is equal to, let's divide this, is equal to 2,800 plus 17 over 60. Then add, we have 2,897 over 60, and if you divide them, it is approximately 48.28 degrees. So these 48 degrees 17 minutes, we will change it into 48.28 degrees. Next is, we are going to use, or let's find the height of the building now. So we are going to use the TOA, or the opposite over adjacent, the tangent. Then we have done theta is equal to opposite over adjacent, or the height over the wide. Then tangent, our theta is 48.28 degrees, and the opposite is the height. So the height of the building over the wide, which is 112.2 feet. Next, so y, let's multiply the tangent. Let's multiply the tangent 48.28 degrees and the 112.2 feet. So if you multiply them, you will get 48.28. So y is equal to 125.84 feet. So this is 125.84 feet, but this is not the final answer because we have to add the 5 feet, which is the height of the transit. so that we will get the exact height of the building. So we will just have to add it into 5 feet. If we add it into the 5 feet, we will get 130.84 feet. So this is our final answer. So this is the height of our building. So we have the fourth problem. From the top of the tower, 63.2 feet high, the angles of depression of two objects situated in the same horizontal line with the base of the tower and on the same side of the tower are 31 degrees 16 minutes and 46 degrees 28 minutes respectively. Find the distance between the two objects. So let's illustrate the problem. So we have here the building. So this is the ground and this is the sky. So this building is 63.2 feet high. Then it is said that the angles of the depression of the two objects situated from the same horizontal line of the base of the tower. So let's say these are the objects, and if you are at the top of the tower, the angle of elevation. So here is the angle of elevation. This is too big. So let's label these as the angle A and the angle B. Then here the angle A is 31. We have 31 degrees 16 minutes. So let's convert the angle A into decimal. So our angle A is equal to 31 degrees 16 minutes. So the 31 degrees, let's add to the 16 times 1 over 60. 31 plus 16 over 60. We have the approximately of 31.27 degrees. So we have 60. This is our angle A now. Then our angle B, we have the 48 degrees and 46 degrees 28 minutes. So let's change sides. So we have 46 degrees and 28 minutes. Let's change. We have 46 plus 28 times 1 over 60 is equal to 46 plus 28 over 60. Our angle B is approximately 46.47 degrees. 46.47 degrees. So now, let's find the height or the distance between the two objects. So we are going to use the tangent, and it is opposite over adjacent. So we have first, okay, let's say that this is the distance distance 1 and the distance 2. So this is the distance. The object is here. So first, let's find the distance number or distance of 1, the first distance. So we have tangent. Okay, let's change again sides. We have tangent, angle A, or A is equal to opposite over adjacent. So our opposite is height, the height over this is the height over the adjacent. So our adjacent is this, the height over the adjacent, which is the distance 1. So next is tangent. Angle A is 31.27 degrees is equals to height, which is 63.2 feet over distance sub 1. Next is distance sub 1 is equal to 63.2 feet over tangent 31.27 degrees. So let's calculate using the calculator. So we have first distance is equal to 104.27 feet, or 27 feet, yes. So this is our first distance. So next, let's find the second distance from the building to the second object. So the process is the same. We have tangent B. Tangent angle B is equal to height over the distance 2. Then tangent, our angle B is 46.47 degrees is equal to height is 63.2 feet over the distance 2. So our distance 2 is equal to 63.2 over the tangent 46.47 degrees. So distance 2, let's divide using the calculator. 63.2 divided by tangent 46.47. So our distance 2 is 60.04 feet. So in order to find the distance of the two objects, we have to add the distance 1 and 2. So to find the distance of the two objects, we have to add the distance 1 and the distance 2. So our distance 1 is 104.27 feet plus the distance 2, which is 60.04 feet. If you add them, the distance is 164.11 feet. So this will be our final answer. So we have the fifth problem. A river flows at the rate of 1.5 miles an hour. So A, in what direction must a man swim in order to go straight across if his rate of swimming in still water is 2.5 miles an hour? B, how long will it take him to cross if the river is 1/2 mile wide? So first, let's solve the letter A problem. So the problem is in what direction? So first, let's illustrate the problem. So we have the river, then he needs to cross he needs to cross with a velocity of 1.5 miles per hour. So this one, or this his rate of swimming in still water is 2.5 miles per hour. So let's make the 2.5 miles per hour the hypotenuse. So let's say that this is the river. Then you need to cross in a rate of 2.5 miles per hour. Then in what direction? The question is in what direction. So the theta here, the theta or the angle here is the direction. So in order to get the direction, we have to use the cosine. And it is adjacent over hypotenuse. So cos theta is equal to adjacent over hypotenuse, which is our adjacent is 1.5 miles per hour, and our hypotenuse is the 2.5. Cos theta, so if we divide the 1.5 and 2.5, so we have 0.6. Next is the theta is equals to cosine negative 0.6. Then our theta or our direction is is 53.13 degrees. This is our direction. So the next problem is how long will it take him to cross the river if the river is 1/2 mile wide. So let's illustrate another. Let's have another illustration. So our theta here is already given, so which is 53.13 degrees. How long? And this is the 0.5 miles. Or let's say 1/2 mile is equal to 0.5 miles. This is the width of the river. Then the question is, how long? So this is our time. And so what we're going to do is we will use the TOA or the tangent, which is opposite over adjacent. So first, that's tangent. This is the letter B problem. Tangent theta is equal to opposite over adjacent. It is, the opposite is, or the tangent is 53.13 degrees over the opposite, which is 0.5 miles, divided by the adjacent, which is the x over 1.5 miles. The adjacent is x over 1.5 miles because we can't get that, we have no hypotenuse, so we are going to use the fraction. Then our x is equal to 0.5 multiplied by the tangent 53.13 0.13 degrees and 1.5. So if we use the calculator, we will going to have a 0.25 hours. Yeah. So this will be our final answer in letter B. We have the sixth problem. A barge is being towed north at the rate of 15 miles an hour. A man walks across the deck from west to east at the rate of 6 feet per second. Find the direction and the magnitude of his actual velocity. So first, let's illustrate the problem. So the boat is, or the river, the barge is going to the north, like this. So it is going to the north in a rate of 15 miles per hour. 15 miles. 15 miles per hour. So it is heading to the north. Then it across from 6 feet per second. West to east from 6 feet per second. So let's find out the direction of and the magnitude of his actual velocity. So let's find first the theta of the triangle. But before that, we will have to convert the 6 feet per second into the miles per hour. So let's convert. So we have 6 feet. 6 feet per second. Let's multiply into 1 mile over 5,280 feet. Because 1 mile is equal to 5,280 feet. Next, let's multiply again from 60 seconds over 1 minute. 60 seconds over 1 minute. And another is 60 minutes to 1 hour. So we have 60 minutes and 1 hour per hour. So if multiply all the numerators, we will get 6 times 1 times 60 times 60. So we have 21,600 over all the denominator. So we have 1 times 5,280 times 1 times 1. So we have 5,280, obviously. Then let's divide and we will get 4.09 miles per hour. Yeah. So instead of 6 feet per second, we will be using 4.09 miles per hour. So let's change this one. We have 4.09 miles per hour. So now let's use the tangent, which is opposite over adjacent. So we have tangent theta. The tangent theta is equal to the opposite, which is the 15 miles, over the adjacent, which is the 4.09. Then let's divide. Let's divide 15 divided by 4.09. So we will get tangent theta is equal to 3.67. Then theta is equal to tangent, shift tangent multiplied by 3.67 and we will get 74. Our theta is 74.75 degrees. Next, we are going to, so we already we already solved the theta or the direction. So next we have to find the magnitude. Next, but we are going to use the Pythagorean theorem, which is c squared is equals to a squared plus b squared. So our c squared is this, the hypotenuse, and the a squared and b squared are the sides of the triangle. So our c squared is equal to a squared. It depends on you which side you're going to assign to a. So but I will be using 4.09 squared plus 15 squared. So the square of 4.09 is 16.78 or 7281 or 16.73 plus 15 squared is 225. So if you add them, you will get the 241.7281. Next, we will get the square root of both sides. So square root of c squared is equals to c, and the square root of 241.7281 is 15.55 miles per hour. So the direction and magnitude of his actual velocity is 15.55 miles per hour, 74.75 degrees.
So we have the seventh problem or the last problem here. The radius of a circle is 100 feet. Find the perimeter and the area of a regular inscribed pentagon, and B, a regular inscribed decagon. So first, let's solve the letter A, a regular inscribed pentagon. So pentagon has 5 sides, a polygon that has 5 sides. Then we will draw a circle, and our radius is 100 feet. So this is our radius, the blue straight line. Then we will draw a pentagon inside a circle because it is said that inscribed pentagon, meaning the pentagon is inside the circle. Then let's connect every corner to the center, and as we can see, we have formed a triangle. So to solve the perimeter and the area of a inscribed pentagon, we will use the ka in SOHCAHTOA, which a cosine which is adjacent over hypotenuse. So first we have here theta is equal to 360 degrees over 5. We will divide the 360 degrees because a circumference is 360 degrees and a pentagon has 5 sides. So every angle in this triangle is 72 degrees. Next, a perimeter is 5 times side, and the area is 1/2 n r squared sine times 360 degrees over n where n is the number of sides. So this formula is applicable in every inscribed polygon. Um, it can be used to hexagon, inscribe decagon, inscribe octagon. This formula is um, very applicable. Then we will take a portion here, a triangle. So this is one of a triangle of a pentagon. So the 30, the 72 degrees we have, or we divide it into two, so it is 36 degrees. So if we put a line here, then this is the height. It will become the height of a triangle. Then the leg is 100 feet since the radius is 100. So this is the leg, and here is the leg, 100 feet. And the side, which is here, the side of the pentagon. So we will going to use the cosine. Cosine theta is equals to h over hypotenuse, or the adjacent over hypotenuse. Your adjacent here is the height of the triangle. Then cosine 36 degrees, the theta is given, is equal to h over 100 feet, which is the leg or the hypotenuse. Then h, we will multiply cosine 36 degrees times 100 feet. So our height is equal to 80.90 feet. So since the height is already given, we are going to solve the side here. So we will be using the Pythagorean theorem formula. We have a squared plus b squared is equals to c squared. A squared plus 80.90 squared is equals to 100 squared. A squared, the square of 80.90 is 6,544.81 is equals to 10,000. Then let's transpose this one to the right side. So it will become negative. A squared is equal to 10,000 minus 6,544.81. So let's subtract, and we have a squared is equal to 3,455.19. Let's get the square root of the both sides. So we have the square root of a squared is a, and the square root of 3,455.19 is 58.78 feet. So this is the um, side, but this is not um, the real measurement of the side. 58.78 feet is only this one, or this line, from the height, from the base of the height to the leg. So we will multiply it by 2 so that we can get the real measurement of the side. So we have 117.6 feet. So our height is already given, and our side is already given. So we can now get our perimeter, which is 5 times side. Our side is 117.56 feet times 5. So we have 587.81 feet. This is the perimeter of our inscribed pentagon. So next, we have A is equals to 1/2 and r squared sine 360 degrees over n, where n, or let n, is equals to the number of sides. So our area is equals to 1/2. Our n is 5 times 100 squared sine 360 degrees over 5. Area is equals to 1/2 times 50,000 times sine 72 degrees. And we have A is equal to 25,000 times 0.95, and our area is 23,776.41 feet squared. So next, the letter B, the inscribed decagon. So um so um To get the perimeter of the inscribed decagon, we have perimeter is equals to 10 times side, and the area is the same. A is equal to 1 half n r squared sine 360 degrees over n, where n is the number of sides. So I used star since it is a decagon. It has the star, it has 10 sides. So as you can see, the inside of the star, we can form a shape which is the um pentagon that we solved earlier. So I will be using the saw or the sign, which is opposite over hypotenuse. So first, let's get a triangle here, and this is what it looks like. So the angle is 18 degrees, because 72 degrees divided by 2 is equals to 36. So every angle here is equal to um 36 degrees. So in this triangle, we have the half of the 36 degrees is 18 degrees. So the leg here is the hypotenuse, and this is the height. So this is the base here, which is already given, which is 117.56 feet. So sine theta is equals to opposite over hypotenuse. So we have sine 18 degrees. The theta is already given, is equal to opposite is 58.78 feet, which is the half of our side, over hypotenuse. So the leg or the hypotenuse is not given. So hypotenuse is equals to 58.78 divided by sine 18 degrees. So we have hypotenuse is equals to 190.22 feet. So this leg or one side is equal to 190.22 feet. So in order to get the perimeter, we have to multiply the side or the hypotenuse into 10. So we have 10 times 190.22 is equal to 1902.2 feet. So this is our perimeter. And the area, 1 half times 10, because it is decagon has 10 sides, times 100 squared sine 360 degrees over 10. Then area is equals to 1 half times 100,000 sine 36 degrees. And the area is equal to 29,389.26 feet squared. So this will be our area. Thank you.